Okay, so we're going to redo C. This is video 31, and in the previous video, we didn't quite do D, but we did do C. There was a very obvious mistake. We just have the slope formula, and I forgot to transfer a negative when I erased the board. I forgot to transfer over a negative, blah, blah, blah. It's not important. So the entire, just misplace one negative, and the entire rest of the problem is wrong. But anyways, we redo C. So, what is the partial? We haven't talked too much about partials because, I mean, we've talked a lot, but if we kind of do something that we didn't go over, like a notation thingy, it's not that big of a deal. We just do all of it how we learned it because there's always that contradiction that technically we need a little bit of calculus 3, but nobody's had calculus 3. So everybody has to learn partial stuff on their own, partial derivatives. But anyways, this is C here. That's what we're doing. So first we take the partials of that. And this is one notation for partials. That just means the partial of the entire thing. Partial of f with respect to x is 1/3. X to the negative 2/3, yes. And of course, y to the 2/3 is held constant. Yeah. So this stuff simplifies pretty easy here. It's going to be y to the 2/3 over 3 x to the 2/3. Yeah. Okay, so then we do the partial with respect to y. This is the simplest notation there. And that's the 2/3 comes out front. Just x to the 1/3 is held constant, and it's y to the negative 1/3. What is it? Y to the 2/3. We would never write that. Y to the 2/3 minus 3/3. We don't show this work. Will become a y to the negative 1/3, but we're skipping algebra under the assumption that we all know the basic algebra. So we have to be algebra masters and all of that. Okay, so this is 2 x to the 1/3 divided by 3 y to the 1/3. So in the end, these things turned out nice and neat here. It's all just notation. The notation is harder than the math. So we've gone over it, jokingly, we've gone over it in like 5 or 10 videos already. But that whole slope equation is delta y over delta x. It's negative, so not here, but later is when I messed it up. Partial of x over partial of y, yes. So I just remember that those are opposite of each other. That's how I remember it. All slopes is the change in y over the change in x. It's the only slope that exists. And on the other side, it's x over y. So it's a very easy thing to memorize. Yes. So the delta x is going to be this one. Yes, and then times the flip of the other one. Yes, and threes cancel. Let's not forget that negative there. That's what I forgot last time. So it is just going to be y over x. Can we kind of shove that on the side over there? Is that okay? And there's a 2 in there. I see negative y. Yeah, negative y over 2x. So we had all this correct last time. This is all correct, and I just forgot that negative y over 2x. Okay, so clear that, negative y over 2x. Yep, so this time we don't make the mistake. It is a slope, so just call it m is negative y over 2x. Hopefully that's what we had before. So once again, for the third time, just in the last video, I forgot that negative, and that makes everything just go completely awry. Okay, so we have that right there. What is that? That's y less than or equal to negative x, uh, negative x plus 2. So what do we have here? So the first thing is the slope of our contour lines. We don't have to draw these things if we don't want to. All the Cobb-Douglas is the same. We have our contour lines, which is kind of like a what is that word? I'm just getting way off subject here, which is a rational expression. Y equals 1 over x. Just never mind all this. But we draw them all the same. We draw it like a y equals 1 over x. And then we have our straight line. And that right there is always where the maximum is. but we set the slopes equal. What we always do is set the slopes equal. We don't have to graph or know much about what we're doing. The solutions are always the same. So the slope of the contour line, we're going to get to this in chapter 3. They go by different names in chapter 3 and 4. ISO, let's not go there right now. But that's the contour line. So we have the slope is negative y over 2x, and the slope of our y equals mx plus b is just going to be -1. I didn't go too fast over that, did I? We do know that that's simply a y equals mx plus b, where the m equals -1. So m equals negative y over 2x, which equals -1. The negatives are gone. Yes. Okay, good. So negatives gone. Y equals 2x. Yes. So what do we have here? That's the relationship that's the relationship that we have. We have that relationship. Okay, so it seems as though we already used our constraint. We already used our constraint, but the answer is actually that we didn't use our constraint. What did we use? We used the slope out of our constraint. But we do have two equations, two unknowns. We have this equation we just made, and we have our constraint, which it doesn't matter if it's greater than or equal to less than or equal to. With the Cobb-Douglas, it's always going to be less than or equal to anyways. But you get rid of the inequality, and we just have negative x plus 2. So we have y equals a thing and y equals a thing. So 2x equals negative x plus 2. I see 3x equals 2. I see x equals 2/3. Hopefully we have it correct this time. So once we know the moves, it is always the same moves with the Cobb-Douglas. Always, always, every time. D, which we're going to do next, is a crazy one, absolutely crazy, but it's all the same steps in a row. So basically, we don't even have to know what we're doing. There's only a max. It's not hunting down a min and a max. There's only a max. So we've already found the x value guaranteed where we're going to have our maximum. So what do? We have our two equations, plug it into the easy one, y equals 2x. Yep. So y equals 2x. I see y equals 2, 2/3 equals 4/3. So we have x and we have y. What are the instructions? Find the x and y that maximizes the f of x, y. So we have to remember that 2/3 and 4/3. We're basically done here now. That's 2/3 and 4/3. Definitely looking a lot more logical than the previous one, yes. And then don't forget where we're coming from. We're coming from him, yes. So we're coming from that. We don't have to write all the work. It's just nice to write it nice and beautifully in a nice 10-minute video. 10-minute video is always very nice. So f of 2/3, comma 4/3 equals 2/3 to the 1/3, 4/3 to the 2/3. Does this thing simplify at all? What do we have? I see a 2. If we kind of do all of that, oh, well, it's to the 2/3 there, to the 1/3. Boy, I should be able to simplify that as I can simplify right there. It's not really same base, is it? So 2 to the 1/3, 4 to the 2/3 over, yeah, so we do have 3 to the 1 at least. It's 3 to the 1/3 times 3 to the 2/3. So it's just 3 cubed root. Yes, so we have 2 to the 1/3, and we have 4 squared.